Welcome to our top-tier security series. This is the 100-day IEC 6243 Mastery. Subscribe now and join the challenge. Let's master it together.
Imagine a massive industrial plant running at peak performance. Pressure systems are stable and operators see nothing but green lights. Then, without any warning from the sensors, centrifuges begin to spin out of control and physically tear themselves apart. There are no intruders in the building, no one planted a physical explosive. The damage isn't the result of mechanical failure or a structural flaw. This scenario highlights a shift in the nature of conflict. A digital attack has crossed the threshold from the screen into the physical world, turning lines of code into a kinetic force. Historically, industrial systems were designed with a singular focus: physical reliability and human safety. In this analog era, cybersecurity wasn't a consideration because the machines weren't part of a network. Engineers relied on air-gapped security. The assumption was that if a controller was physically disconnected from the internet, it was impossible to hack. For years, that physical separation was the primary defense. That separation disappeared as industries integrated machinery with IT networks. By plugging factory floor equipment into corporate systems, companies gained real-time analytics and remote monitoring. While this digital transformation improved efficiency, it also systematically dismantled the air gap. The once isolated control logic was now accessible through the same networks used for corporate emails. This vulnerability was exploited on a global stage by Stuxnet. It was the first documented case where a digital virus was used to physically dismantle an industrial process. Stuxnet didn't target personal data. It specifically searched for programmable logic controllers and modified the logic governing their physical speed. It forced centrifuges to spin destructively while simultaneously sending fake data. Operators saw normal readings while the equipment failed. Stuxnet provided the proof that a remote attacker could manipulate physical reality while leaving the people in charge completely unaware that anything was wrong. Since then, threats evolved across a timeline. Phase 1 was accidental exposure. Phase 2 was malware spillover unintentionally disrupting machinery. Today, phases 3 and 4 involve targeted disruption and precision manipulation. Attackers intentionally engineer code to sabotage specific industrial gear. This shift changes the stakes of a breach. In the IT world, an attack might cost money or compromise privacy. In the industrial world, an attack targets the power grid, the water supply, and the safety systems that protect human lives. Protecting these systems requires a specialized approach. You cannot defend a physical process using only the tools designed to protect digital data. As the threat moved to the factory floor, the limitations of traditional IT security became obvious. Standard defensive tools were built to secure databases and servers, not high-pressure boilers or turbines. The conflict is operational. On a corporate network, you can isolate a laptop or reboot a server to install a patch. You cannot simply reboot a controller that is managing a volatile chemical process or a heavy robotic arm in motion. Organizations realized that the standard IT response, patching and rebooting, could actually cause the very equipment failures and safety risks they were trying to prevent. They needed a framework built for the physical world. That framework is IEC 62443. It was developed specifically to address the unique vulnerabilities of industrial control systems and the physical processes they manage. It provides a technical blueprint for security. This includes rigorous risk assessments and zone segmentation, which creates digital barriers around specific pieces of equipment to prevent an attack from spreading across the entire facility. Industrial disasters rarely happen because the machinery is inherently weak. They happen because the defensive strategies used to protect them haven't kept pace with the evolution of the threats. Mastering this evolution is the first step toward building a defense that actually works. Tomorrow, we'll dive deeper into the technical friction between these systems and explain why traditional IT security inevitably fails in an industrial environment.
Welcome to the Cybersecurity Forum. Don't forget to subscribe to this channel and like the video. This is to get the latest cybersecurity news and updates. Stay secure with us.